We present a framework to generate full-body poses using only the position and orientation of a headset and controllers as input. First, we train a single policy with reinforcement learning to imitate 10 hours of diverse mocap data. Here you can see 4,000 characters of different sizes training in parallel, simulated in NVIDIA's Isaac Gym. Here we show the trained policy evaluated on synthetic sensor data, shown by the green dots. After the policy is trained, it's able to distinguish what type of motion the user is performing, whether a walk, jog, backwards walking, and transitions. This is achieved without any sensor information of the lower body. The users shown here are not part of the training dataset. We encourage the viewer to pause the video and compare the similarity of poses. For motions where the lower and upper body are less correlated, it is more difficult to accurately imitate the user. However, physical constraints such as balancing, inertia, and contacts help synthesize reasonable estimates. We also show that the 6D pose of the headset alone, without any controllers, carries enough signal to reconstruct a variety of motions with reasonable accuracy. This is where the physics constraints really help to synthesize motions without any foot skating, foot hovering, or other unphysical artifacts. All the motions shown are directly generated by NVIDIA's PhysX simulator. This allows us to easily add other simulated objects into the scene and have the tracked character interact with it. The fact that the avatar pose is influenced by the environment can help increase realism of the synthesized motions. If a user controls an avatar in an environment different than their living room, the motion is slightly adapted to fit the rough ground of the virtual world. In the previous videos, we showed a single policy that is able to track users of different height. Here we performed some very preliminary tests where users control avatars that have different dimensions than themselves. This type of retargeting might open up some avenues for future research to allow users to be embodied by whatever avatar they choose. Since the avatar motion is simulated without non-physical root forces, it can be difficult to imitate dynamic motions for which the avatar hasn't learned that skill yet. Here you can see the avatar falling, trying to imitate the quick sprinting and stopping motions present in the Lafont dataset.